here we are going to learn about, or relearn about inequalities. Okay, now we have these symbols, right? We have the less than symbol, we have the greater than symbol, and we use these in the place of an equal sign, less than or equal to, when the two things that we have aren't equal, when one is more than the other. Or maybe it could be more, maybe it could be equal. And in order to represent this situation, we often use a number line to graph and say, okay, well, this number could be, it can't be, let's say 5. It can't be 5, but it can be any of these numbers less than 5. Or it can't be 2, but it can be any of these numbers more than 2. Right? This is how it looks on a graph. Or, this number, x, whatever it is, can be 4. Notice the closed circle says, yeah, I can make the value of this number 4, or whatever this is on. It can also be these numbers less than 4. Or, yeah, it can be 6, or any of these numbers more than 6. Okay? And here, you could just memorize each of these, right? But it's useful to just kind of see the patterns here. Here, let's see if we can't just kind of summarize. You can have either a closed circle or an open circle, right? And you can shade either left or right. Now, notice, closed circle, shaded left. Notice I'm making like a little table here, right? Closed circle, shaded left. That's this one, less than or equal to. Open circle, shaded left, is less than. So what we notice is, if it's a less than symbol, if this arrow is pointing to the left, we shade to the left, right? Because that's a less than symbol, and that means I want to include all the numbers that are less than to the left of a particular number. Now, if it's or equal to, I also use that closed circle. Mr. Gain likes to say, if I use extra ink on the sign, I use extra ink on the graph. That's his way of remembering it. Okay, now greater than on the flip side, here I'm going to use a closed circle for that or equal to, right? Because that's saying, yeah, it can be this number, but it can also be more than this number if it's going to the right, shade to the right. Okay, so either way, but these are just things that you just have to kind of memorize and know. Right, so let's try this out. So let's say I have x is less than 3. So here's 3 on a number line, like here's 2, here's 4. X is less than 3. Now, is x allowed to be equal to 3? Like, if I said, I'm thinking of a number and it's less than 3, would you guess 3? No, you sure wouldn't, because I said it's less than 3. So it doesn't include 3, so I use that open circle. But numbers less than 3, like, would you guess 4? Nope. You might guess 2, though. And not only could you guess 2, you could guess 2.5. You could guess 1.25678, right? You could guess negative 100. All those numbers are less than 3. And so this, shading to the left, says, yeah, all these numbers less than 3, all of them forever, those are the numbers less than 3. What about x is greater than or equal to negative 2? Okay, now negatives, you got to be a little bit careful, right? Because negative 2, what's the number less, what's 1 less than negative 2? It's negative 3, right? Like here's 0, and then the negative numbers, they go back kind of in reverse order. But if a number is greater than or equal to negative 2, so it could be equal to negative 2. So yep, we can put a nice closed circle on that. And then this is greater than. The numbers that are greater than negative 2 are this way. So negative 1 is greater than negative 2. 0 is greater than negative 2. And then all these numbers, 1, 2, 3, 4, 5, 6, 7, forever, right? Those are all greater than negative 2. Okay, so that's going from this to this. Now sometimes we'll ask you to go the other way. Right? We give you a graph and see if you can figure out. Let's put 4 right here. Let's do this. How would you write that? right? And here's what you do, right? I would like x, 4. You say, okay, closed circle or open circle? Oh, closed circle. Okay, shaded left or right? Shaded left, right? Notice my arrow points the same as this arrow. Okay, do another one. It's that one. Okay, I'm going to put x, put -3. Look, you do it. Pause and do it before I do it. Ask yourself, open circle or closed circle? Oh, open circle. Okay, so I'm not putting that line underneath. Which way is it shaded? Shaded to the right. That's greater than. Point the arrow to the right. Okay. Now the other thing you might be asked to do is to solve inequalities. Now, solving inequalities is just like equations, except, just like equations, except, just like equations, except 2 things. Number 1, the variable, the x usually, must land on the left. Okay, so that means you either have to make it land on the left at some point while you're solving, or you need to flip it at the end. Okay, so but the variable must land like this. Like this is not okay. Whoops. This is not okay. Okay, we want the variable on the left. Okay, and then second, when you multiply or divide, now listen, not just by anything, by a negative number, you flip the sign. Okay, I'm going to do a couple examples, and then you're going to do a practice problem. Okay, right now as your listening check, go ahead and draw a smiley face right there. Okay, so if you're listening, you'll draw a smiley face right there, and I'll know you're listening when you submit your work. Here are your examples. Now remember, solving inequalities is just like solving equations. So what would I do first here? Well, I deal with addition and subtraction first. So I'm going to subtract 8. Okay, and notice I'm squeezing the work just a little bit. For me, I'm using composition book. I'm going to run out of space a little bit here. So this 8 minus 8 is 0. 23 minus 8 is 15. Okay, now this is x being multiplied by -5. Right, that's x being multiplied by -5, so I'm going to divide by -5. And I have to think to myself here, first of all, positive divided by negative is a negative. Okay, 15 divided by 5 is 3, -3. But this right here, when I divide by a negative, that step leads my sign to flip. Okay, x is greater than or equal to -3 is my answer here. Over here, I have a decision to make. Because in order to get x on just one side of the equation, I could either add 2x or I could subtract 6x. Either way, I'm going to end up with a situation. If I add 2x over here, I'm going to end up with my x on the left side, and I'm going to have to flip it at the end, which is fine. If I subtract 6x over here, I'm going to end up with a negative number being multiplied by x, and when I divide by that negative number, I'm going to have to flip the sign. Either way, it doesn't matter. Just be aware of your options. Okay, I'm going to go ahead and add 2x to both sides. And I get 7 is less than 8x minus 9. Okay, now I want x by itself. I'm going to add 9. I'm going to divide by 8 because this is x is being multiplied by 8. And I get 2 is less than x. Okay, and here is where this is not an acceptable answer. Okay, for inequalities, you're going to take the whole thing, you're going to flip it. Now watch. I put the x on the left and the 2 on the right. The sign has to flip too. See how the mouth is open towards the x here? That means the x is greater than the 2, right? So we still need to make sure the mouth is open towards the x. So notice the sign flips around as well. Okay. Here are your practice problems, and if you are using a composition book like me, which is a little bit smaller, you might be running out of space right now, but just squeeze them in. Write a little bit smaller. 14 is greater than 2x plus 6. Okay. And remember, you're showing all the work for these because I'm about to give you the answers. So the answers are not what I care about. Okay, so copy those down. And we'll call this number 1 and number 2. Copy those down, work on them. I'm going to show the answers right now. And remember, I need to see the work when you submit. And the answers are here. Okay, so that's what you should get. If you don't get those, ask for help.